of the 4.3 notes. 4.2. I have one. No, I have a couple extra copies. Does anyone need the notes? It's just the last page of these.
4.3?
Yeah, 4.3.
Yeah, I was here Monday. I need those.
We'll start on this page.
I did too.
See if I can dig a. 4.2, my last one. And then we will continue on, do some review problems. No, these are today's notes. Once we finish this last page. These are Alex problems. So yeah, we're just going to finish this a little bit, and then we're going to review 4.1, 4.2, 4.3. And on Friday, we'll start 4.4. There's only 4.4 and 4.5 left. And just to kind of review the syllabus, we talked a lot. Remember, this Friday is not an online class, it's in class. Next Friday is the online class. That is the OTC 25 anniversary celebration.
So no classes after morning?
Yes. So I got an email about it a couple whiles back, but I mean, that's all I've really heard from it. I think if you're on campus, they're having pizza and cake and ice cream or something, and then raffles. Here they're doing.
I know, like,
I think there's
you're
a
supposed to wear your OTC stuff
that
all
week.
Next week.
Yeah, they're doing some kind of celebrations. Yeah. So we're just to make up for that. We'll just do an online lecture. Piece of tape. So last time we talked about these graphs of logarithmic functions, and the exponential functions, domain and range, it's going to be flipped for the logarithmic function. There's really only one interesting point in the logarithmic function, and it's either going to be kind of a growth or a decay in a sense. When b is a number between 0 and 1, which really doesn't come up a lot, but if it is, if the base is like a half or a fifth or 0.5, I'm running out of options here. Typically we see the natural log and log base 10. So most of them are going to kind of follow this curve. It has a vertical asymptote of the y-axis. And of course, if I shift the x any, that vertical asymptote is going to shift. Just like we had a horizontal asymptote for the exponential function, if I shifted it up or if I shifted it down, that horizontal asymptote would shift as well. Shifts can affect the range in the exponential function. It's going to affect the domain in the logarithmic function. Here's the interesting things that can happen. The A, if the A is positive, or sorry, if the A is negative, it can reflect it about the x-axis. If it is in between 0 and 1, it shrinks it vertically. And if it is greater, if the absolute value of A is greater than 1, it's going to stretch it vertically. This way. However, it's not that interesting because it continues on forever, minus infinity to infinity. So any kind of stretching, still not that interesting because if you zoom out, you can't really tell it's been stretched. So let's look at, first off, the domain. One thing that we want to stress, we can never take a negative number. We can never take the log of a negative number. The reason why this corresponds to 2 to some power is 2x plus 4. Maybe not x, let's put y. right? 2 to the power. 2 to any power can never be negative, right? The domain of the exponential function, sorry, the range of the exponential function is always positive numbers. They never output a negative number, right? So the domain here is going to be specifically when 2x plus 4 is greater than 0. Can't even equal 0. So if I subtract 4 from both sides, I have 2x is greater than minus 4. Divide 2 from both sides, x is greater than minus 2. So I have minus 2 to infinity. That would be my domain. I could write this.
It's always greater than.
It's always greater than 0. And if I factor out a 2 here, I can see that this x plus 2 is shifting the x, the 2 units to the left. So the domain minus 2 to infinity. You don't have to go to that level. You just have to focus that whatever I'm inputting into my log function has to be positive. You can never input a negative number to log. And if you have your calculator, you can try to take log of minus 5, and it's going to give you an error. You take log of 0, it's going to give you an error. It has to be greater than 0. So these are all the numbers that is in the domain of this function. It has to be greater than minus 2. See that? What about b? I need it specifically when 5 minus x is greater than 0. So 5 is greater than x, or I can write that x is less than 5. 5 greater than x, x less than 5, that's saying the same thing. If I were to kind of draw a number line here, and I have 5, it's going to be this part shaded in here. So it's minus infinity to 5 is my domain.
So it does not include five, right?
It does not include 5 because it can never equal 0. This is going to be important when we actually get to 4.5, when we talk about solving equations, because you might get a possible solution. You have to check to see does it even make sense. So you might end up with 0 and 10 could be possible solutions. But 0 would be the only solution because I couldn't plug 10 in this equation. It wouldn't make sense. So they're called extraneous solutions. So you have to go back and make sure that it's in the domain. So eventually, we're going to come up with problems at the very end. Hold in 4.5. Oops. We're going to come up with equations. See if we can get some logarithm like this, where we had to solve for the x values that satisfies this relationship or this equation. And we have to make sure it's in the domain that this cannot equal 0 or be negative, and this cannot equal 0 or be negative. So we're going to come up with possible more than one solution. We have to test each one to make sure it's in the domain. So that's kind of where that comes from. Of course, we'll also graph them. There might be shifts to the left, shifts to the right, up or down. Let's look at the examples. So these should be review. How would I rewrite log base 3 of 1 over 81 equals minus 4? Good. 3 to the minus 4th power is 1 over 81. That's the exponential expression to this equation. What about ln of 5 equals y? Exactly. E to the y equals 5. Now remember here, I can use those properties of logs for it to cross out, and I could say 3 and 3. So the 3 to this power would cross out the log base 3, and I would get 3 to the minus 4th equals 1 over 81. The same thing here with ln. To cross out ln, I need e, because the base of ln is e. So if I do it to the left-hand side, I got to do it to the right-hand side, and I get e to the y is 5. You guys see that? So it doesn't always have to be an equation. It can be an expression, and you can be asked to evaluate it. So log base 3 of 27 is asking you 3 to what power is 27? Right, so here I could say, what does this equal? I don't know, I want to find out and call it y. So if I take 3 to this power and 3 to this power, I get 27 equals 3 to the y. So here y equals 3. You can also think of it as what power three gives you 27. That is what log base 3 of 27 is saying. What power of 3 gives you 27? Here's an example of graphing using the domain and range. Log base 3. So this is the general form of log base 3 of x. You guys see that? The base is 3, so it's greater than 1. So it's going to approach 0 to the right. It's going to approach that, and it's going to go down to infinity, and then it's going to come up and go off to infinity. And it goes to the point 1, 0. I can take that general equation and shift it. Right, so I have this vertical asymptote here. The x plus 1 is shifting the whole thing to the left 1 unit. So I shift this over 1 unit. So that shifts the vertical asymptote 1 unit. So this now becomes x at minus 1. I have a vertical asymptote. The plus 2 shifts it up 2 units. So this point now becomes 0, 2. And then everything else follows the same shape. On Alex, if they give you the graph, you just pick it up, shift it over to the left 1 and up 2, and everything stays the same. When you go to graph it, you want to make sure you show that there's this vertical asymptote here. Okay. In the exponential function, all you have to show is a horizontal asymptote. And if there's any shifts up or down, it would affect the horizontal asymptote.
So how does it go over 1?
Here,
And it goes up to
this, up over. So it doesn't really matter the order. You were probably used to seeing log base 3 of x plus 1 plus 2, but it doesn't matter if they put that plus 2 at the beginning or the end. So what is the domain? Looking at the graph, what's the domain? Very good. Originally, it was 0 to infinity, but we shifted it to the left 1. Shifting to the left or the right is going to affect the domain. What's the range? Yeah, it doesn't. You can't do anything to affect the range in a logarithmic function. It's always going to be minus infinity to infinity. Just like you can't do anything in an exponential function to affect the domain. It's always minus infinity to infinity. I see that? Personally, I like to graph it and then get the domain and range for my graph. Domain is the x values, range is the y values. But you don't necessarily have to. You can get the domain and range algebraically, where the domain is going to be all real numbers, that it's going to be all numbers that make the logarithmic, what's inside the parentheses, positive. So x plus 1 has to be positive. And if I solve from that algebraically, x plus 1 has to be positive. That tells me x has to be greater than minus 1, which is what I get for the domain there. So there's kind of two ways to look at it. The domain of this function could be clear by just saying x plus 1 has to be greater than 0. The range for logarithmic functions is always going to be minus infinity to infinity. So you don't necessarily have to graph it. So that finishes up 4-3, the first day of notes. Oops, wrong. 28. We switch to send to OneNote. Chapter 4. Okay. So here we're doing problems from Alex. So I just want to go over some of these if you got to them on Alex, or if not, 4-1 to 4-3. One-to-one function, G and H are defined. G is just a relationship of points, and H is an actual function. This is asking us, what is the inverse for G? What is the inverse of minus 6? What do I need to put in G to get out minus 6? 4.
Oh.
Right? Because it's the X and the Y. So here, this is asking me, what do I need to put in G to get out minus 6? So this is kind of the Y value. What corresponding X value gives me a Y of minus 6? And that would be 4 here. So this notation is a little disconnected because typically we think of functions. But it could be points. It could be these are the X values, and these would be the corresponding Y values. So if I gave you the inverse function at Y, you could find the corresponding X that would output that. What is the inverse of H? So I'm looking for a function. H of X is 2x plus 9. X minus 9 over 2 is correct. So as we go through that, Y is 2x plus 9. I switched the role of X and Y. Right? Now I just solve for Y. So I have X minus 9 equals 2Y. Divide both sides by 2. That would be H inverse of X. So H inverse of X would give me X minus 9 over 2. What would be H of H inverse of minus 1? You could go through and say, okay, plug minus 1 into the inverse function. So that would be minus 5. Then I plug minus 5 into the outside function. What would I get? what does the inverse function do? It undoes what the original function does, right? So if I plug in -1 to my inverse function, then I plug that number into my original function, I get out what I originally put in. So let's go through some of you. This would be -1. H of H inverse of X is always X. So let's see, what is H inverse of -1? -1 minus 9 over 2 minus 10 over 2, which is -5. What is H of -5? 2 times -5 plus 9 minus 10 plus 9, which is -1.
So it just would be X minus 5 2.
What?
Would it just be X minus 5 2 for that little step?
For this?
Yeah.
For H inverse of X?
Yeah.
Yes, it would be X minus 9 over 2. But H of H inverse of any number would be that any number. And you can test that by plugging that first number into the inside function, getting out something, plugging that to the outside function, you should get back out what you originally put in. So H of H inverse of A would be A. Ha ha.
So if you got the answer right.
I got one person. What?
So if you got the answer right, your answer should always match the what's in the.
Yes, exactly. And that's a good way to kind of check if your inverse is correct. By plugging in something, getting out something, plugging that into the original function, and hopefully getting back out what you originally plugged in, right? So kind of what we're doing is we're plugging in X, we're getting out Y. We plug Y into the inverse, we get out X. And that's kind of what is kind of shown here. If I plug this into the inverse function, I get out 4. If I plug 4 into my original function, I get out -6. That's a way to verify something's an inverse as well. Question?
She didn't get her review.
Oh, sorry, yes. She's taking care of you. Anyone else I miss? Okay. Oh, guys, speak up. Okay, so another way to present this on Alex is just ask you to find the inverse function, and hopefully we did enough of these on that quiz. You guys still comfortable? This is about the most difficult level question you're going to get, where you have to multiply both sides by a denominator. So the process here is have y equal 8x minus 9 over 7x plus 5. Go through and switch the role of x and y. So if I do that, I end up with x equals 8y divided by 9, 7y plus 5. You guys remember doing these? So at this point is where the algebra comes in. You have 7y plus 5 times x equals 8y minus 9. I would suggest you write these parentheses. That way you know to distribute this x. It's probably the #1 common mistake on this problem. The students lose that x being multiplied to both terms. So now I have 7xy plus 5x equals 8y minus 9. The next thing is to get y by itself. So I need all the y's on one side and everything else on another side. So let's say this term and this term. So I'm going to kick this one over here. And then I want this term and this term. So I'm going to kick this one over here. So 7xy minus 8y equals minus 9 minus 5x. Doesn't matter which side you put the y on. I want this y and this y on the left-hand side. So I need to subtract 8y. and then I need to subtract 5x. You guys follow me there? And then we factor out a y in both these terms, so I'm left with a 7x minus an 8 equals a minus 9 minus 5x. My last thing to do would be divide both sides by 7x minus 8. So I get y equals minus 9 minus 5x divided by 7x minus 8. And the last thing to do is to call that the inverse. So this might, kind of seem long, a little tedious. If you want to star it, I guarantee you one of these will show up on the next test, and one of these will show up on the final at this level. Some of the, the one we did above it was algebraically a little easier to do, because all you have to do is subtract the 9, divide by 2. This takes a little bit more work, but it's the exact same process. Any questions? The next one is testing, can you plug in your calculator? This has to do with inflation, the rate of inflation. The current price of the item is $3,000. How much is it going to cost in 10 years? So you're going to take what is the price in 10 years. So that's going to be 3,000 times 1.039 to the 10th power. And it says round to the nearest dollar, which in a financial math class, they'd say round to the nearest cent. So when inflation would say something that cost $3,000 10 years ago is going to cost $4,398 now. Again, problem like this on Alex is, can you just plug this in your calculator? And follow the instructions with rounding. If they want to round it to the nearest dollar or nearest cent. So you guys kind of see the type of problems I've kind of been stressing to you. Those will probably be the ones that will be on the exam, ones that show up on the final from this section. The bottom three are just writing logarithmic equations. So if I have an exponential equation, e to the y is 7, what would that be in logarithmic form? Of 7, yeah. So one way I can do this is I need to cancel that e. How can I cancel e? I can take ln of both sides, right? So if I take ln of this side and ln of this side, the ln of e cancels and I get y equals ln of 7. So you don't have to memorize.
So ln and e
Are
ln
inverses.
is the inverse of
ln is the inverse of e, yes. What's the inverse of 10? Log base 10. What's the inverse of 7 to a power? Log base 7.
I didn't see where you put your parentheses on there.
So I take ln of this side and ln of this side. Ln of all of this and ln of all of this.
okay, and ln
You could
is sort of
technically
e.
take out the
So ln of e to the y equals ln of 7. But ln of e to the y is y.
I'm kind of like, you couldn't do E though and have it E to the 7.
In this example,
Yeah, to get the only thing that can get rid of it is the ln.
yeah. The only thing that can get rid of a base is a natural log or a log. So if my base is b, I take log base b of both sides. Here my base is e, so I'm taking log base E, which is a special name, which is ln. Same thing here. How can I get rid of this 7 to a power? I can take log base 7 of both sides, right? So if I write this, log base 7 of 7 squared equals log base 7 of 49. Log base 7 of 7 squared is 2, right? Because the log base 7 of 7 cancels, and I'm left with a 2. So this is saying log base 7 of 49 is 2, which would be 7 squared is 49, which is what we get here, right? They're just different way to write the exact same expression.
So in this one, you'd want us to leave it at the log though on the test.
Yeah, because that's what it's asking for. What we had here, that was the original expression. Rewrite as a logarithmic equation. Or I could give you the logarithmic equation and have you write it as an exponential equation. They're inverses of each other, so they cancel each other out. We can also have evaluate. What is this asking?
It's asking like, what is it?
So yeah, so I could say, I don't know what this is. I'm going to call it y. And I need to solve for y. This is also saying 7 to what power is 1 over 49. So if I take 7 to this side and 7 to this side, I have 1 over 49 equals 7 to the y, which is kind of where we get this from. What would be your answer? Negative 2. So some of it will be translate an exponential function to logarithmic or a logarithmic function to an exponential, and some of them will be just evaluate. Any questions on that kind of stuff? If we have time after the notes, I'll pull up Alex and show you kind of how to input some of these. Most of it's pretty straightforward on the graphing. It just depends on if it wants a horizontal asymptote or a vertical asymptote and maybe 1 or 2 points to go ahead and graph it. Don't get a little disconnected because sometimes students can do it all day on Alex, but then you give them a blank piece of paper and they're like, I don't have any points to plug in. You do. They're just right there. You just have to physically do it versus Alex gives you the grid, gives you a little pencil. And so you might also just try to do it on a pencil and paper as well, because that's how your test is going to be presented. If I ask you for the domain and range of this function without graphing it, what would be the domain? Okay, the 3 is shifting up or down. Does that affect the domain? Yeah. It would be 0 to infinity, right? Because this is telling me x has to be greater than 0. Right? That's all. There's no shifting left or right. So what would be the range? Yeah, it wouldn't change at all, minus infinity to infinity. The plus 3 actually does not do anything here. It shifts it up 3 units, but I'm still going from minus infinity to infinity. However, if you graphed it, hopefully you would be able to see the domain and range. So let's graph this here. My vertical asymptote doesn't change. There's no shifting. Originally, my point would be 1, 0, right? This would be 1, 0 if this was log base 2 of x. Log base 5 of x is going to look exactly like this. Log base 611 of x is going to look exactly like this.
When does it go 0? When does it start at 0?
That's for the exponential function b to the x. B to the x, this would be 0, 0, 1. And you have a horizontal asymptote, right? The vertical asymptote corresponds to flipping it about the line y equals x, which means you switch the role of x and y, so this point is 1, 0. That's what it means to be an inverse, right? So this would be log base b of x. If b was greater than 1. If b is a fraction, it actually goes this way. And we might do one like that on Alex. So that's just kind of a refresher there. So back to our graph. The plus 3 just means I move this up 3 units. So I'm still at 1, 3. So the blue line would be log base 2 of x plus 3. Does not affect my domain, and it doesn't affect my range because my range goes from minus infinity to infinity. Shifting up or down a logarithmic function will not affect the domain or the range. Only shifting left or right is going to affect the domain. You guys see that? Just looking at this function, can you tell me the domain? Would it be 0 to infinity?
That one would be the
Would it be? So what do I want to focus on? This has to be greater than 0.
oh,
Right? X minus 3 has to be greater than 0, so x has to be greater than 3, right?
okay.
So 3 to infinity. What is the range? Minus infinity to infinity, right? I can't affect that. So if I go to graph this, my vertical asymptote is going to change. Originally it was at 0, but I'm shifting it to the right 3 units. So 1, 2, 3. So this is at x equals 3, which makes sense because my domain is 3 to infinity. Originally, my point would be here at 1, 0. I shift that over 3 units, so it's at 4, 0. That's my only interesting point. Well, there's millions of points, but I think it's interesting because it's crossing the x-axis, but other points could be just as interesting. So you could just plug in a point. This is going to give you something that's going to be that you're going to be able to calculate. Right? If I plug in x equals 4, this is saying log base 4 of 1 equals what? 4 to the 0 is 1. That's why my y value is 0. And you can plug it in your calculator if you can change your base to 4. Log base 4 of 1 is 0. Log base anything of 1 is always 0. That's why we start at that point 1, 0. That's because b to the 0 is always 1. You guys see that? So people are very disconnected to what it means to take the log of something. So I think these kind of are good questions to ask. Why is log base 4 of 100 between 3 and 4? What is log base 4 of 100 saying?
Basically, it is asking like 4 to the what power?
Is 100, right? That's very good. So this is saying 4 to the x is 100. So what's 4 cubed?
64.
64. What's 4 to the 4th power? 256. So you can see how 100 is in between 64 and 256. So the x value has to be between 3 and 4. Right? You can use your calculator and say, what is log base 4 of 100? 3.3. So then if you say, what is 4 to the 3.3 power? So, of course, this keeps going, right? It's an approximation, which is 97. Yeah. So do you guys see why log base 4 of 100 has to be between 3 and 4?
So if that was on a test, that's how you.
Yes, that's how you'd want to answer it. What about log base 3 of 97? It's the same thing, right? This is saying 3 to the x equals 97. 3 to the 4th is 81. And 3 to the 5th, 243. So we're expecting 97 is between 81 and 243. So that is why our answer here is between 4 and 5. Because 3 to the 4th is 81 and 3 to the 5th is 254. Why is it not possible to find log base 3 of minus 9? Yeah, because we're looking for 3 to what power gives us minus 9? There's no x, or we can say 3 to the x is never negative. Here, 5 to the x is never negative. So that is why you can never take the log of a negative number, because there's no corresponding base to that power that will give you negative numbers. It doesn't make sense. So that's why sometimes when we get to 4.5, 4.5 is just a summary of all this chapter 4. So if I get an answer that gives me a negative value of my log inside my parentheses for my log, I have to discard that answer. The last one here, graph the following functions, state the domain, range, and the equation of the asymptote. So we want the domain, the range, and the equation of the asymptote. What's the domain going to be? Very good. So the domain is minus 4 to infinity. What's the range? Yeah, infinity, minus infinity to infinity. And the equation of the asymptote? So it asks for an equation, right? So you guys got it's at 1, 2, 3, 4, right? What would be this equation? X equals minus 4. Right? This is when x equals minus 4. My original point was at
That's the answer is x equals minus 4
for the equation of the asymptote. And that's, I mean, graphing it is one thing, but this knowing also that this is x equals minus 4, which would be this line. So originally, if I would have graphed this log base 2 of x, I would be at the point 1, 0. So if I shift that over 4 units, I'm at minus 3, 0. So this would be log base 2 of x plus 4. You don't have to graph the original function here. It's pretty clear. I could take this point and shift it 1, 2, 3, 4. Does anyone have any questions on Alex with the input? Sometimes students get into, they feel like there's a little disconnect in this section. Try not to get caught up on the graphing in Alex. Make sure you're comfortable graphing it on a piece of paper as well. Let's see if I can go to students view. Another thing I just want to say real quick before everyone leaves, if you're having, Alex grades are really low, and I'm somewhat concerned about that. So if you didn't have a chance to get to one of your pies or one of your assignments, send me an email and I can extend that out. And I'm fine even extending it out when we get closer to the final to be the day before the final exam. Because if you can get in there and bump up your Alex grade, that's just going to make you better off going into the final exam. Also because you're studying the material and because you're actually getting points for it. So some of you are like, I can't even practice this because I can't get into the pie or the homework. And I see where that's frustrating. So send me an email out, or I might end up just extending it all out to the final exam anyway. I'm a little hesitant to do that because I know how that works. Because last minute is going to be last minute, and I want this next exam to be decent. And I would, this next exam and even the fourth exam, if you guys can do really well on that, there's a lot less pressure going into the final. So I know grades are a lot of you are kind of concerned about your grades at this point. It's not over until it's over, but you guys still have to put in the work. So I want to give you guys that opportunity. Calculator question?
Just got